Hello everyone. Today we are going to start with the second part of our first chapter, that is matter in our surroundings. Now yesterday we had discussed about some few experiments. Let us see that what were those experiments. See, I have already explained you yesterday about how to dissolve solid in liquid. We had discussed the example of potassium permanganate, which was dissolved in water and the whole water turned into blue color. Similarly, we took two separate chambers. In one chamber we filled the red bromine gas, and other chamber was totally separated with only oxygen. When we combined the two chambers by making holes in between, we found that the bromine gas spreaded all over because both the chambers turned red, which showed that the bromine gas also spread it, just like the potassium permanganate crystals also spread it in the water. So these two things clearly explain the phenomenon that the matter are made up of tiny particles. So this thing is, firstly, we can see because the particles are not easily visible, and these particles are moving constantly, which means that these are moving from one place to another. So these are the two things which we should know. Now this first thing, the first phenomenon which we talked about was what? This was diffusion. So from diffusion only we come to know these things, that matter is made up of tiny particles and the particles are moving constantly. Now what things we understood from the Brownian motion? The first thing we understood was that the particles are very small. Again the same thing, you can correlate. Now the question can be framed that what are the similar observations of diffusion as well as the Brownian motion phenomenon. So first thing is this only. The second thing that Brownian motion explains is that between the particles there are spaces present. Means spaces are present between the particles. We have one particle here. Supposedly we have one particle here, one here, one here, one here. So you can see that there are some spaces between the particles. These are known as space. These are the space between the particles. Now what is the significance of this space? This space somewhere or the other helps these particles to move from one place to another. So these were the two things. Now what are the further things? Let us see. The third observation which we saw was that the particles are moving constantly. Now the particles are moving constantly, this thing also we studied about in the diffusion. So you can see that the two things are very much related. Both the diffusion phenomenon explanations are given in this Brownian motion also, and this one is very important, that the particles are attracting each other, which means that if this is one particle and this is one particle, so it will be like this, that this particle tries to go there and this particle tries to come here. In this way we can say that the particles are also attracting each other. This is only explained by Brownian motion and not the diffusion. Now let us see all of them one by one in detail. The four things that we understood in the Brownian motion. The first thing is that the particles are very small. Now let us see it on the basis of experiments that we perform. Now when we keep water to this KMnO4, or when we add this water to KMnO4, what happens is it gets diluted. This is not diluted, it is diluted. Okay, so what happens is KMnO4 crystals are there, but since we are adding water to anything will dilute the thing. Okay, dilute means it will reduce its concentration, and the water now fades its color. Now how does it happen? That was actually the purple color of potassium permanganate, which is now fading itself. It means the small particles of KMnO4 is still made up of smaller particles which keep on spreading and imparting color on more and more dilution of water. So this is the thing, is that we have the small particle of KMnO4, but this is made up of still smaller particles. Okay, and these smaller particles keep on spreading, and that's why, because of that, we come to know that when we add more and more water, more and more KMnO4 particles can be seen over there. Now see, if this is our KMnO4 particle, here we still have more small particles around this, which can keep on diluting as we add more and more water. So this is that the particles are very small. The second thing is that the particles have spaces in between, which shows that these can move continuously. Now let us see the example. On dissolving sugar in water, there is no change in the volume of water. It specifies that the particles have even space between them and these are not tightly packed and are loose. See, what happens is, if we had very tight arrangement of particles, that time what would have happened? If we had added directly, suppose this is our water level till here and we had very solid particles. Now when we added these particles inside this, what would have happened? That when we added it over here, this water level would have risen. But has it happened on dissolving sugar? No. Which shows that these sugar particles, the particles of sugar, have the spaces between them. The next is the particles are moving constantly. Now how can we prove this? You must have seen the when the food is cooked, what happens is its aroma or its smell reaches to the distant places. Means if we are sitting in the next room, then also the smell of that food can reach till over here. It means the particles are moving there. You can now easily say that if something is cooked in a plate, so its smell is coming out and that can reach very different places. So this shows that the aroma is spreading. Now these things which you can see over here, these smoke particles which you can see, these are nothing but these are the particles only which are moving from one place to another. Okay, on adding a drop of ink to water, its whole color changes. Now why it happens? Because that drop of ink, all the particles of the drop moved all over in the water and because of that we saw that the whole color of water changed. The next is that the particles of matter attract each other. Now how can we prove this? You have seen the alum crystal. The alum crystal have alum atoms whose force of attraction is very large. Now if you have seen or not, if we have water, okay, and this water is supposedly, this water is full of dirt. Now what happens is when we add alum crystal to it, now what happens is that whole of the dirt, when we are adding alum crystal to it, now what will happen is that this whole of the dirt accumulates over here only. There will be no dirt left around, which shows that this alum crystal has attracted all of the dirt particles from water, which shows that the particles of matter can attract each other. Now there are some forces of attraction also, if you see. So forces of attraction, we should know that solids have the highest forces of attraction, then we have the liquids, and then we have the gases. Now this shows that the highest force of attraction is in solids, then there is in liquids, and then there is in gases. You should also know if there is more and more force of attraction, then the velocity of the particles will be less. It means that in gases the particles are moving at the highest speed, whereas in solids the particles are moving at the very less speed. This is a very important question according to examination. Now we talk about the rigidity and fluidity. These are the two different terms. These are used to explain two different things. One is rigidity. Rigidity means how stable something is, and fluidity means how something can flow. If something is flowing, which means that it is not stable. It is very simple thing. Now first point is that if the forces of attraction are more, now what will it denote? If forces of attraction are more, then that matter is rigid and it will be ultimately solid. Okay, if we have more and more forces of attraction, which means that the particles are more close to each other, and if they are more close to each other, we can say that this is nothing but a solid only. So we can say that this will be a solid and the solid will have the greatest force of attraction. If we try to make a comparison for this force of attraction, we come to know that solids will have the highest force of attraction, then will have the liquids, then will be having the gases. Now second is if the forces of attraction are less, which means that these are the fluid, means which have the tendency to flow. Liquid and gases, both of them are fluid. You should know that the liquid and gases are fluids. Not only the liquid but the gases are also fluid, which shows that they can flow. We have already seen this example of gases in that bromine gas experiment. Now let us see some of the questions. Now you should do these questions by yourself. The first is that give reasons why gases are fluid. Now this has been already explained over here above. You can see from over there, you have to give the relation between the forces of attraction and the velocity of particles. Now this is what we can solve it over here only. You see, that if we have more forces of attraction, it means that the particles will be tightly packed. So it will means that the particles will not move because they will not have a space. It means that their speed will be less. Means what we are trying to say is that more the force of attraction, lesser the speed. So this is the formula, that force of attraction is inversely proportional to speed. Very important formula. Directly in the examination it will come. So this is the one. And the third is give the phenomenon that are explained by Brownian motion, explained in detail. The four phenomena that we studied. Now this is generally of this down question. We have this of 5 marks, this is of 2 mark, and this is of 1 mark. These can come in the examinations. That's all for the day. Thank you and have a nice day.